Okay, here's the calculus question, and let's just get started. We have this formula here that we're given in our formula sheet. For first principles, whenever they say it, you go right to it. You have to do this. The derivative is a limit as h approaches 0. H is the change in x, but the change in y is f of x plus h minus f of x. That's the change in y. And what you should do is just work it out first. So f of x plus h means you take x plus h and you rub out x and put x plus h. And that's it. And then the rest of f of x, which is minus 6, you write it down. You just replace x with x plus h. And then you're supposed to subtract f of x, so you put a bracket and put whatever f of x is. Well, there's your first step. Now you expand this, which is always x squared plus 2xh plus h squared if it's a quadratic. Then you subtract 6 here. Then you subtract 3x squared, but minus, hey, you'll have a plus 6 here. Now we're ready to sort of do some canceling. 3 times x squared is 3x squared, but minus 3x squared, that's gone. 3 times 2xh, that's 6xh. And 3h squared here, and you've got this minus 6 plus 6, it cancels too. Now we're ready to write down f prime of x equals the limit as h approaches 0, and the change in y, this f of x plus h minus f of x, we just put it right there. Now you can factor this h out and see that you're going to be left with an h on the top and a 3h there, and the h's are going to cancel. Or you can just look at it. H divided by h is going to give you 6x. H squared over h is h. Now we're ready to think about the limit. If h is approaching 0, becoming infinitely close to 0, then the derivative, the rate of change of x over y over x is becoming infinitely close to 6x. And that's the derivative. It tells you the gradient at any x value along the curve. That's a big sentence I just said. That's what it's all about. Now there's a shortcut for finding the derivative. All you do is multiply the exponent times the coefficient and subtract 1 every single time. This one's all set up, ready to go. 6 times 5 is 30, x to the 5th. 3 times 2 is 6, not 9, it's 6. So we're going to change that to a 6. And yeah, I'm going to do it right now so I don't forget. Change it to a 6. So 3 times 2 is 6 x squared. And then the derivative of 3x, 1 times 3 is 3. And that's x to the 0, which is 1, so it's just 3. There's the first one done. The next one, it's just not in the right form. This x, square root of x, you must make it x to the half. And you see that 6a? If you try and find dy dx, the derivative with respect to x, that's just a constant. It's not, doesn't have an x in it, so the derivative's 0. Now that you've written x to the half, you go a half times 2 is minus 1, but 1 half minus 1 is minus a half. 4 times 3 is 12, and then you bring it down 1, x cubed. So there's that question all done. Now this one, it's not in the right form because you need separate packages of something times x to a power. Well, you just put the 3x separately underneath each thing here. Now x cubed divided by x is x squared. And this is really 1 over 3. That's your number in front. Here's minus 2 over 3 in front. But x to the minus 2 divided by x to the 1. You go minus 2. When you divide, you subtract. This is really x to the minus 3. Now you're ready to multiply. 2 times a third, bring it down 1. 3 minus 3 times minus 2/3, well, the minus 3's will cancel. You'll just be left with plus 2. And a minus times a minus is a positive. And you bring it down 1, it's to the minus 4. Well, there's all the first part of the calculus question.